So then you're going to do some math here. And let me undo. I made a mistake. Okay, so 1 plus 1 is even. That gives us 2. Oops. Now we're going to do some quick math where we have 1 plus 1 is 2. That's even. 2 plus 1, nope. 3 plus 1, yes. 4 plus 1, nope. Yes. Nope. 1 plus 2, no. Yes. And it follows the same pattern. And so on and so forth. Because all of these that are circled are even, and all of them that are crossed out are odd. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So the probability of having an even with 2 dice, 1 roll, would be 18 out of 36. And if we simplify that, we get 1/2. Now we could go and ask another question. Well, what then is the probability of having an odd with a roll? Well, you could go back and count up all of the odds, but having it be an odd is the same as saying it's not even. So what's the probability of it not being even? Well, for it to be even is 1/2. There's a chance that it is going to be even, and therefore the complement, which is it being odd, is going to be the rest of the probability, which in this case is 1/2. So the probability of it being odd, or the probability of it being not even, is the same thing as saying it's equal to 1 minus the probability of it being even. Because highest probability is 1, and if it's even, it's not odd. I hope that makes sense to you. All right, we're going to clear the board and do another problem similar to this. Okay, now we are going to talk about flipping a coin, flipping 2 coins 3 times. So you have your first coin, and you have your second coin, which I'll put here in a white color. And then we have our 3 flips. And I will do them in yellow. So this would be our sample space. So on your first coin, for each flip, we could either get a heads or a tails. We could get heads, or we could get tails. Let me redo this table. 1 second. Okay, I actually think this way of making the table is going to make it a little bit easier for you guys to understand. So on your first flip, With your first coin, you could get heads, or you could get tails. Same with your second flip, you could get heads, or you could get tails. And on your third flip, you could get heads, or you could get tails. That's for your first coin. So we have a red coin here. All right, now for your first flip with your second coin. You could also have the same two outcomes. You could have heads, or you could have tails. But since you're flipping these two coins at the same time, we do have to consider more than what is going to show in this table, which is why I'm showing you it to be careful. So on your second coin, which we've got our white coin here, on our first flip, we could flip heads, or we could flip tails. On our second flip, we could flip heads, or we could flip tails. And on our third flip, we could flip heads, or we could flip tails. So this is our sample space for each individual flip. But on our first flip, we could either get heads, tails, or heads, heads, or we could get tails, tails, or we could get tails, head. But really what we're saying is you can get tails, tails, you can get heads, heads, you can get tails, heads, mixed. Now since we're flipping them at the same time, TH and HT are the same thing. We don't care which coin is red and which coin is white. We're just saying there's two coins, we're flipping them at the same time. We want to talk about the probabilities of these. Same thing with your second flip, you can get tails, tails. You can get tails, heads, which is the same thing as heads, tails, we don't care. Or we could get heads, heads. And for our third flip, we could get heads, heads. We could get heads, tails. We can get tails, tails. Or we could get head, tail. Okay, so what we do want to consider are HT for our head, tails versus tails, heads, is that it has the same likelihood. It's 50% chance. Even though these two are the same and we're not differentiating them, you can get a heads on the first coin and a tails on the second at the same probability. You can get a heads on the second coin and a tails on the first coin. So why this matters is in case you come across a problem, sometimes you're not going to consider a repeated outcome, and sometimes you are. It depends on what the question is asking you. Okay, so we are going to ask, what is the probability of getting the same on both coins? Probability of having the same on both. So let's count those options. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 possible outcomes, which is always going to go on the bottom. And how many of these outcomes are both on the same side of the coin? Tails, tails. Heads, heads. Nope. Tails, tails. Heads, heads. Nope. Heads, heads. Tails, tails. Nope. So we have 1, 2, 3, 4, 5, and 6. So we have 6 out of 12, which is equal to 1/2. Therefore, the probability that they are opposite out of these 3 flips is equal to 1 minus 1/2, because this is the prime version or the complement of our same on both sides, because the rest of the outcomes are the opposite. So we get the same thing equals 1/2. All right, we're going to do one more example together, and then you have an exit ticket. All right, so this one, we're also going to roll our 2 dice, and we want to know the probability of it being a 1, let's redo that. Let's have it be the probability of the sum of the numbers being less than 5 and not 1. Okay, so later we're going to learn about how to use this and in a different way, but for today we're going to set up our table just like we did before. We have our 2 dice, and we're rolling them 1 time. I'm going to go ahead and set up the table. Okay, now that I have drawn out our table, we're looking for any number that is less than 5. And we're going to change this and not odd. Okay, this is less than 5. We're going to circle all the ones less than 5, less than 5, not less than 5, less than 5, less than 5, and the rest of them are greater than 5. So, and it's not odd. Is this not odd? Okay, so this gives us 1, because 1 plus 3 is 4. 2 plus 2, not odd, 2. And we have our 1 plus 2, that is odd. 1 plus 1 is 2, that is number 3. 1 plus 3 is 3, that's odd, and 1 plus 3 is 4, which gives us number 4. So, instead of including these, first we make sure it meets this condition. So all of these added up to less than 5, and we don't want it to be odd. So we only had 1, 2, 3, 4 options that were not odd, and we're less than 5 out of our 36. When we reduce that, we are going to get 1/9. So our probability is 1/9. All right, stay tuned for your exit ticket. Here's your exit ticket. Please pause the screen, read it carefully, answer the 3 questions asked, and submit your bell work before the due date. I will see you all next week. Have a great weekend.